So today we're going to be talking about tangent and velocity problems. So the word tangent is derived from the Latin word tangus, which means touching. That means that the tangent to a curve is a line that touches the curve. In other words, a tangent line should have the same direction as the curve at the point of contact. So for example, if we have a curve like this, the tangent line at this point, it would be something like this, and it would be negative. And the slope of the original curve was also negative. And if you have a tangent at this point, it would be positive. If you have a tangent at this point, the slope of the tangent would be 0. However, if you have a curve like this, the tangent to this point would be something like this, and it would be undefined. So next we're going to talk about how you actually find the slope of a tangent line. So suppose you have point P, which is C comma f of C, and you have point Q. And the distance between the x coordinates of P and Q is delta x. So then the coordinates of Q would be C plus delta x comma f of C plus delta x. And so if you were to find the slope of the secant line, which would be this line, you would use y2 minus y1 over x2 minus x1, which is right here, and then you'd simplify and you'd get something like this. However, if you wanted to find the slope of the tangent line, which is when the distance between point Q and P is 0, you would find the value as delta x approaches 0. So let's go ahead and do a practice problem. So the problem is, find the equation of the tangent line to f of x equals square root of x minus 1 at x equals 5. So we're going to start with the generic equation and then plug in 5 for c because we're solving for when x equals 5. And then we're going to plug in these values to the original equation, and then we're going to simplify, and we're going to get the limit as delta x approaches 0 of square root of 4 plus delta x minus 2 over delta x. Our end goal is to cancel out the delta x's. In order to rationalize the numerator, we're going to multiply this by the conjugate. And after you do that, you're going to get 4 plus delta x minus 4 over delta x times square root of 4 plus 2. You can cancel out the 4's and then cancel out the delta x's from the top and the bottom. And then you get 1 over square root of 4 plus delta x plus 2. And then you can just plug in 0 for delta x and solve. So this would be the slope of the tangent line. Next, what we have to do is, if you want to find the equation of the tangent line, we can use y equals mx plus b. We know what the x value is, which is 5. We can plug that into the original equation to find the y value, which is 2. And then we know what the slope is, so you can plug everything in and solve for b, and then you can get y equals 1/4 x plus 3/4. It is important to note that the type of limit that is used to find tangents and velocities gives rise to the idea of the derivative. Next, we're going to talk about velocity. The position function is the function that gives the position relative to the origin of an object as a function of time. And this is what the position function is. G is acceleration due to gravity, v0 is initial velocity, and s0 is initial height. Now, to find the average velocity, you would do something like y2 minus y1 over x2 minus x1, which would be the change in distance over change in time. And it is important to note that velocity is speed with direction, so it's a vector. The instantaneous velocity is when the change in time is approaching 0. So it's basically the tangent to a certain point in time on the position function. So let's go ahead and do a practice problem. The first thing I like doing whenever we have a word problem is to draw a picture. I find this to be extremely useful. So the first question asks, what is the position function for the coyote? This is the original position function, and we can just plug in values we know. We know that the initial height is 900 feet. And because this problem is in terms of feet, the value for the acceleration due to gravity we will be using is negative 32 feet per second squared. And so the position function would be negative 16t squared plus 900. The next question asks us to find the average velocity for the first 3 seconds. So this is from time 0 seconds to time 3 seconds. And we will do this by finding the position at time 3 minus the position at time 0 over 3, so that we find the change in distance over the change in time. And we'll do the same thing when we want to find the average velocity between 2 seconds and 3 seconds. And these are basically the slope of the secant line. Next, we're going to study what happens to the velocity as we get really close to 3 seconds. So first thing we're going to do is find the average velocity between 2.5 seconds and 3 seconds. And so then you would find the position at 3 seconds, subtract that from the position at 2.5 seconds, and then subtract 3 seconds from 2.5 seconds. And you'll get negative 88 feet per second. Now you're going to make that time interval even smaller, and you're going to find the average velocity between 2.9 seconds and 3 seconds. And that would be negative 94.4 feet per second. And you're going to make it even smaller and find the average velocity between 2.99 seconds and 3 seconds. And that would be negative 95.84 feet per second. And then you're going to make it even smaller and find the average velocity between 2.999 seconds and 3 seconds. And that would be negative 95.984 feet per second. Make sure to include units or else you will miss points on the test. By using these values, we can estimate what the velocity should be at exactly 3 seconds. And we can estimate it to be about negative 96 feet per second. So now we're going to find the instantaneous velocity at t equals 3 seconds. So we're going to do this by finding the limit as delta t approaches 0 of s of t plus delta t minus s of t over delta t. Now t is going to equal to 3 because that's when we're looking at the instantaneous velocity. And then we're going to plug in, and so you're going to plug in 3 plus delta t into the original position function and s of 3 into the original position function as well. And then you're going to simplify, and then you're going to end up with negative 96 delta t minus 16 delta t squared over delta t. You can cancel out the delta t's, and then you're going to plug in 0 for delta t, and you're going to get negative 96 feet per second. Don't forget the units.